Good morning, everyone. My name is Emar Ibn Hossein Rafi. We are three group members. My another group partner's name is Asif Iqbal Rani, ID 57099. And it's Mabrul Qayyum, student ID is 64537. So today I will be presenting module A of our cybersecurity research project titled Encrypted Ecosystems Tor versus HTTPS. The project was completed as a part of a simulated research initiative funded by the Australian Department of Home Affairs. The purpose of the research was to investigate and compare two important encrypted ecosystems. The Tor network, which focuses on anonymity, and HTTPS, which focuses on secure communication. We examined their architecture, cryptographic algorithms, routing and mechanism, and implications for cybersecurity and law enforcement. Before discussing Tor and HTTPS, it is important to understand the different layers of Internet. The surface web consists of publicly accessible websites indexed by search engine. Although HTTPS encrypted data, network observers can still see metadata such as IP addresses. The deep web contains that is not indexed by search engines, such as online banking system, academic database, the private portals. The dark web is subset of the deep web that requires specialized software, such as Tor browser. To access it, users .onion domains and rely based on routing to cancel both user and server identities. Tor, the anonymous network. Tor, which stands for the onion router, is designed to provide anonymity. Instead of connecting directly to a website, Tor routes traffic through the relay nodes known as guard node, middle node, and exit node. Data is protected, though layered encryption, often referred to as an onion encryption. Each relay removes only one layer of encryption, and meaning that no single relay knows both the source destination of communication. Tor also uses the NTOR protocol based on Curve 25519. Diffie-Hellman key exchange to establish secure sessions keys with each relay. So my other partner Asif will be presenting afterwards. Thank you.
Hello, I am Asif Balrani. In this slide, we're going to talk about Tor live evidence. To validate the theory, we used Tor browser and examined a live Tor circuit. The circuit showed three relay nodes, a guard node located in the United Kingdom, a middle node located in Germany, and an exit node also located in Germany. This practical evidence demonstrated how Tor separates knowledge between relays. The guard node knows who the user is but not where they are going, while the exit node knows the destination but not the user. This architecture is what provides anonymity within the Tor network. So the public encrypted service, HTTPS, is the standard protocol used for secure web communication. It combines HTTP with TLS version 1.3 to provide confidentiality, integrity, and authentication. The TLS handshake uses ECDHE key exchange and derives session keys using HKDF. Once established, communication is encrypted using algorithms such as AES-256 GCM and or CHA-20 Poly 1305. Unlike Tor, HTTPS focuses on protecting the content of communication rather than hiding the identities of the communicating parties. About Wireshark evidence, we captured both HTTPS and Tor traffic using Wireshark. For HTTPS traffic, we observed that the server name indication or SNI field revealed the destination domain name. Source and destination IP addresses were also visible. For Tor traffic, no SNI information or destination domains were visible. Instead, we only encrypted traffic between the user and the guard node could be observed. And the guard node could be observed. This demonstrates an important forensic principle: encryption protects content, while anonymization protects identity. HTTPS secures the data being transmitted, whereas Tor secures both the data and the user's identity. Although both systems use strong cryptography, they have different objectives. HTTPS protects data during transmission between known endpoints. However, metadata such as IP addresses and destination domains remain visible. Tor protects anonymity through multi-hop routing and layered encryption. Both the content and routing information are concealed from observers. Therefore, HTTPS focuses on confidentiality while Tor focuses on anonymity and privacy.
Hello everyone, my name is Mabur Khayyam, student ID 64537. In this slide, I will present law enforcement and national security. Encrypted and anonymous network create challenge for investigators. With Tor, ISPs can usually see only encrypted communication. With guard nodes, hidden services remain particularly difficult to investigate. Because traffic never leaves the Tor network. By comparison, HTTPS traffic still exposes metadata, making it easier for investigators to identify communication patterns and obtain information through lawful channels. Because cybercrime often cross international borders, agencies such as AFP, Interpol, Europol, and the FBI frequently collaborate on the investigation. Encryption method. Several important cryptographic technologies were identified during this research. AES is used for efficient systematic encryption of data. RSA and elliptic curve cryptography are used for key exchange and authentication. TSA 1.3 provides secure communication with forward secrecy. Tor uses one-in routing where multiple layers of encryption protect anonymity and make traffic analysis more difficult. Although these technologies provide strong security, they are not immune to threats such as traffic correlation attacks, malicious exit nodes, and endpoint compromise. To conclude, Tor and HTTPS both rely on modern cryptography but serve different purposes. HTTPS protects the confidentiality and integrity of data exchanged between identifiable endpoints. Tor extends protection by concealing user identity and routing information through multi-hop anonymous routing. As cybersecurity professionals, it is important to understand both technologies, their strengths and their limitations. Future cybersecurity policies must balance privacy, civil liberties, and public safety while ensuring that strong encryption remains available to legitimate users. Thank you for listening. That's all from our part. We're happy to answer any questions.